You think you understand radiation. You learned about it in school. Radiation is energy that travels through space. Radiation is dangerous. Radiation causes cancer. You've heard it hundreds of times. But here's the problem. You don't really understand what radiation is. No one does. Not even the world's greatest physicists can fully describe what radiation really is. They can describe what it does. They can measure it. They can calculate it. But what is it? No one knows, except Max Planck. Planck didn't answer the question directly, but he discovered something that completely changed how we understand radiation. A discovery so profound that it changed the way we see reality. In this video, I'll show you what Planck discovered, why you never understood radiation before, and most importantly, why it changes everything you thought you knew about radiation. Stay with me until the end, because by the end, you'll understand why radiation is much stranger than anyone imagines. Part 1. What you think radiation is. Let's start with what you think you know. Radiation is energy. Radiation travels through space. Radiation can be light. Radiation can be heat. Radiation can be dangerous. You know that. You learned it in school. But here's the problem. You think radiation is continuous. You think radiation is like a flow of energy that travels through space, a flow that can be any intensity, a flow that can be any frequency. You think radiation is smooth, continuous, boundless, but you're wrong. Part 2. The problem no one could solve. Let's go back to the late 19th century. It was 1890. Scientists were confused. They had a theory about how hot objects emit radiation. It was called black body radiation. The theory predicted that you should be able to calculate exactly what radiation would be emitted at each temperature. But there was a problem. The theory didn't work. The best physicists in the world tried. Rayleigh tried. Jeans tried. They used Maxwell's equations. Nothing worked. The theory predicted that hot objects should emit an infinite amount of radiation at very short wavelengths. Ultraviolet wavelengths, infrared, anything beyond the visible. But in reality, this didn't happen. In fact, hot objects emitted very little radiation at very short wavelengths. This was called the ultraviolet catastrophe. And it was exactly what it sounded like. A complete disaster for classical physics. The best scientists in the world couldn't solve it. And then, in 1900, a man named Max Planck looked at this problem and did something radical. He questioned everything. Part 3. The assumption that changed everything. Max Planck made an assumption so strange that he himself didn't completely believe it. He said, what if radiation isn't continuous? What if radiation came in packets? How much? Think about that for a second. All physics up to that point assumed that radiation was continuous. You could have any amount of radiation, a little, a lot, anything in between. But Planck suggested, what if radiation was like coins? You can't have half a coin. You have whole coins, 1, 2, 3, but never 1.5. What if radiation worked like that? He called these units of radiation quanta, plural of quantum. The idea was that radiation came in discrete packets, indivisible. You couldn't have less than one packet. But here's the crucial part. The size of these packets depended on the frequency. The higher the frequency, the larger the packet of radiation. He created a simple equation, E equals hf, where E is energy, F is frequency, and H is a constant. A constant so small that no one had noticed it before. With this simple idea, he solved the black body radiation problem completely, perfectly. The numbers worked. But there was a problem. No one believed him. Part 4. Why no one believed it. Let's be clear. Planck's idea was absurd. At least it seemed that way. If you heat an object, it emits radiation continuously, right? You can see it. The radiation flows. It's a continuous stream. You don't see packets of radiation. You see a flow. So how could radiation come in packets? Physicists at the time were right to be skeptical. The idea challenged everything they knew about the world. Planck himself didn't completely believe it. He thought it might just be a mathematical trick, a way to make the numbers work, but not necessarily the truth about how the universe really worked. He wrote in his notes, "I consider the quantization hypothesis to be purely formal, and I do not attribute any physical reality to it." In other words, he thought it was just a trick. It wasn't real. But here's the detail that changes everything. Even if it was just a trick, it worked. And in physics, if something works, you have to take it seriously. So Planck published his theory in 1900, and the world of physics went into a state of confusion. Some scientists thought it was brilliant. Others thought it was crazy. Most weren't sure. Part 5. The young Einstein proves it all. In 1905, a young physicist named Albert Einstein was thinking about a strange phenomenon called the photoelectric effect. The photoelectric effect was simple. When you shine radiation on a metal, electrons are ejected. Simple. But here's the problem. The energy of the ejected electrons didn't depend on the intensity of the radiation. It depended on the frequency. This didn't make sense with classical physics. If radiation was continuous, as Maxwell had described, then brighter radiation should give more energy to the electrons. But that wasn't the case. Blue radiation, even if weak, ejected electrons with more energy than very bright red radiation. How was this possible? Einstein looked at Planck's equation and had an idea. What if Planck was right? What if radiation really came in packets? What if each packet of radiation had an energy determined by its frequency? So when a photon hits an electron, it transfers all its energy at once. If the photon is blue, it has a lot of energy. If it's red, it has little. Intensity doesn't matter. Only the energy of each individual photon matters. With this idea, Einstein explained the photoelectric effect perfectly, and here's the crucial detail. He proved Planck was right. Radiation really did come in packets. Quantization was real. It wasn't just a mathematical trick. It was how the universe really worked. Part 6. But wait, there's much more. Now you may think, okay, so radiation comes in packets. I get it. What's the big mystery? Here's the big mystery. If radiation comes in packets, then what exactly is radiation? You've learned that radiation is energy that travels through space. But that's not a definition. It's a description of what radiation does. It's not what it is. Think about it. You can't see radiation. You can't touch radiation. You can't pick up radiation and put it in a box. You can see the effects of radiation. You can measure radiation, but you can't see radiation itself. It's like trying to describe the color blue to someone who has never seen it. You can describe the wavelength. You can describe how the human eye responds, but you can't describe what blue really is. Radiation is like that. But Planck discovered something profound. He discovered that radiation is not continuous. It is discrete. It comes in packets. And these packets have a relationship to frequency. This means that radiation is fundamentally linked to frequency, to vibration, to movement. This means that radiation is not a thing, it is a pattern. It is a vibration. It is movement. Part 7. The truth about radiation. Let's think about what that means. If radiation comes in packets, and each packet has an energy determined by its frequency, then what is a packet of radiation? A packet of radiation is a vibration. It is a pattern of motion. It is a wave. But here's the strange detail. A packet of radiation is also a particle, a photon. So radiation is both a wave and a particle. Radiation is vibration. Radiation is movement. Radiation is pattern. But radiation is not a thing. Radiation is a concept. It is a way of describing how energy moves. When you heat an object, you are increasing the vibration of the atoms. You are increasing the frequency of the vibrations. The higher the frequency, the greater the radiation emitted. When an object emits radiation, it is emitting photons. Each photon is a packet of radiation. The energy of each photon depends on its frequency. Blue radiation has photons with more energy than red radiation. Why? Because the frequency is higher. Radiation is frequency. Radiation is vibration. Radiation is movement. But here's the detail that no one can explain. Why does reality work this way? Why is radiation quantized? Why can't there be any amount of radiation? No one knows. Part 8. The mystery remains. Here's the truth that no one wants to admit. No one really understands why radiation is quantized. We know it is. We know it works. We know how to use it. But why? Some scientists think quantization is fundamental, that it's how the universe is built, that at a very deep level, everything is discrete. Everything comes in packets. Others think quantization is just an approximation, that at an even deeper level, everything is continuous. But quantization emerges as an approximate property. No one is sure. And here's the worst part. The more you learn about radiation, the stranger it gets. You learn that radiation can be light. But is light a wave or a particle? No one knows. It depends on how you observe it. You learn that radiation can be heat. But is heat the movement of atoms or electromagnetic radiation? No one knows. It could be both. You learn that radiation can be dangerous. But why? Because radiation can ionize atoms. It can break molecules. It can damage DNA. But how? Why are high-frequency photons more dangerous? Because each photon has a lot of energy. And when a photon hits a molecule, it transfers all its energy at once. If the energy is sufficient, it breaks the molecule. All of this comes from Planck's discovery. All of this comes from the idea that radiation is quantized. Part 9. How this affects you. You may be thinking, okay, that's interesting, but how does it affect my life? Well, let me tell you, everything you do because radiation is involved. You see because radiation enters your eyes. Visible radiation, photons. Each photon has an energy determined by its frequency. Blue light has photons with more energy than red light. You feel warm because thermal radiation heats your body. Infrared radiation, infrared photons. Each photon has an energy determined by its frequency. You eat because plants absorb solar radiation. Photons from the sun. Each photon has an energy determined by its frequency. Plants use this energy to perform photosynthesis, to create molecules, to create food. You communicate because radiation travels through the air. Radio waves, radio photons. Each photon has an energy determined by its frequency. Everything you experience is mediated by quantized radiation, and each packet of radiation is exactly as Planck discovered. Part 10. Practical applications. But wait, there's much more. Planck's discovery wasn't just about understanding radiation, it was the beginning of a much larger revolution. After Planck discovered quantization, Engineers began using this idea to create incredible technologies. Lasers work because engineers understand quantization. They use Planck's equation to calculate exactly what frequency of radiation will be emitted. Solar panels work because photons from the sun hit silicon, and each photon transfers its energy to an electron. The energy of each photon is determined by its frequency. Planck discovered this. Digital cameras work because sensors detect individual photons. Each pixel detects how many photons arrive at that point. That's quantization in action. Microwave ovens work because microwave radiation has a specific frequency. That frequency causes water molecules to vibrate. The vibration creates heat. The frequency is determined by Planck's equation. All modern technology depends on Planck's discovery. Part 11. The Quantum Revolution. But wait, there's much more to it than that. Planck's discovery wasn't just about radiation. It was the beginning of the quantum revolution. After Planck discovered quantization, other scientists began to question other things. What if energy wasn't the only thing that was quantized? What if momentum was quantized? What if position was quantized? This led to the development of quantum mechanics, a completely new theory of how the universe works. And here's the crucial detail. Quantum mechanics is weird, very weird. In quantum mechanics, particles don't have definite positions until you observe them. They exist in a state of superposition in multiple places at once until you measure them. In quantum mechanics, two particles can be entangled, connected in such a way that measuring one instantly affects the other, no matter how far apart they are. In quantum mechanics, you cannot simultaneously know the position and momentum of a particle. The more precisely you know one, the less precisely you know the other. All of this comes from Planck's discovery. All of this comes from the simple idea that radiation is quantized. Part 12. What you really didn't understand. And now we come to the crucial point. What did you really not understand about radiation? You didn't understand that radiation comes in packets. You didn't understand that each packet has a specific energy. You didn't understand that the energy of each packet depends on the frequency. You didn't understand that radiation is both a wave and a particle. You didn't understand that radiation is a pattern of vibration. You didn't understand that radiation is fundamentally strange. You didn't understand that radiation is not continuous. You didn't understand that radiation is discrete. You didn't understand that radiation has a fundamental structure. You didn't understand that reality is quantized. You didn't understand that everything comes in packets. You didn't understand that the universe is made of quanta. And now you know. Now you understand why you never understood radiation before. It's not because the explanation is bad. It's because radiation is strange. It's because reality is strange. Part 13. Why no one can explain it. And here's the most important detail. Why can't anyone explain radiation completely? Because radiation is fundamentally inexplicable in terms of human intuition. You can't visualize a packet of radiation. You can't imagine what a photon is. You can't understand how something can be both a wave and a particle. Because your intuition was developed to deal with big things, things you can see and touch, things that obey classical physics. But radiation isn't a big thing. Radiation is a pattern. Radiation is a vibration. Radiation is a concept. The best physicists in the world still can't describe radiation completely. They can describe what it does. They can measure it. They can calculate it. But what is it? No one knows. And here's the most important detail. No one can explain it because there's nothing to explain. Radiation is not a thing. Radiation is how we describe how energy moves. Radiation is a concept we created to describe energy patterns. It is not something that exists independently. It is a tool we use to understand the universe. But Planck discovered that this tool has a structure, that this tool is quantized, that this tool comes in packets, and that changes everything. Part 14, the final truth. So what is the final truth about radiation? The truth is that radiation is frequency. Radiation is vibration. Radiation is movement. The truth is that radiation is not continuous. It is discrete. It comes in packets. The truth is that you can't have any amount of radiation. You have specific amounts, multiples of a quantum. The truth is that fundamental reality is much stranger than anyone imagined. The truth is that Max Planck discovered all of this, and it changed the way we understand radiation. But here's the most important detail. The truth is that you still don't fully understand radiation. No one does, not even the world's greatest physicists. But now you know more than you did before. Now you understand that radiation is quantized. Now you understand that radiation comes in packets. Now you understand that reality is strange. And that's the beauty of physics. That's why we keep exploring. Because the universe always has more mysteries to reveal. And Max Planck discovered one of the biggest, the fundamental structure of radiation. Part 15. Conclusion. So now you know. You know what Planck discovered. You know why you never understood radiation before. You know that radiation is quantized. You know that radiation comes in packets. You know that radiation is strange. You know that reality is much stranger than anyone imagined. And you know that Max Planck discovered the key to understanding this strange reality. He discovered that everything comes in packets, that everything is quantized, that everything has a fundamental structure, and that changes everything. Because now you understand. Now you know why radiation is the way it is. Now you know why reality is the way it is. And that's the reason you never understood radiation before. It's not because the explanation is bad. It's because reality is strange, and that's the beauty of physics.